Self-servicing is a common practice in university campus canteens, which is to have food trays returned to collection stations or food tray collectors by consumers after meals. The supply of seats and spaces in canteens of HKU are likely to lead to stacking up of trays and spillage of food, worsening the hygiene condition of the canteen and causing a great demand and workload for the cleaners. A conveyor belt is proposed to tackle this problem for improving the quality of experience in canteens. The J-shaped belt is designed for utilizing the limited space in HKU and fits into the habits of diners with the smart material used and the biomimicry design. Let's take a look into the mechanism of the belt. The conveyor belt can be divided into the following layers. The bottom one made of magnets of only one side. The top one will be the one in contact with the food trays, also made of magnets of the same size as the bottom one. A weight sensor will be installed and the contacting side will be coated with an easy-to-clean material. The theory of kinetic architecture is demonstrated in the conveyor belt. The two layers will be elevated beyond the area where the magnetic force is affected. When somebody puts their food tray on a belt, the weight sensor will detect the increase in weight and automatically lower the belt. The belt will be lowered to a height where the magnetic force is activated. As the bottom and top layer have the same size of magnets, they will repel each other and create a kinetic force that drives the belt towards the dishwashing area. Considering conveyor belts are usually extensive and of great scales, like luggage conveyor belts in airports or sushi conveyor belts that move across the stores. Due to the limited space in the canteen, the conveyor belt is not able to have an extensive path. Ideally, the belt should be able to turn and wrap around the food tray collection area. Under such limitation, we learn from the structure of crustaceans through biomimicry. Crustaceans are animals with shells. Despite the toughness from the shells, agility and flexibility of movements are still observed from one specific type of crustaceans, streams. The curvature of the streams can be applied to the surface of the belt design to enable the bending around the corners.
A smart material inspired by biomimicry is also applied into this conveyor belt. Spillage of some food residue onto the belt is likely to happen during rush hours, resulting in an oily surface. These residue will then accumulate on the belt, which become hard to clean over time. If the belt is in bad sanitary condition, odor may be produced and disturb the dining environment. To ease the cleaning duty of the staff, the self-cleaning superhydrophobic coating and oleophobic coating will be sprayed onto the belt. The superhydrophobic coating is inspired by the lotus effect. Due to the low wettability and the contact angle of the surface is higher than 150 degrees, the water will form a droplet-compelling dust and run off easily. The superhydrophobic surface will resist water and dirt to keep the conveyor belt clean and new. Therefore, it requires less cleaning of the staff as well as less maintenance. The application of the oleophobic coating has the same goal. It is an oil-repellent coating that keeps the conveyor belt clean so that the workload of the staff can be reduced. These two self-cleaning materials both result in an easy-to-clean surface. Another concern is that small pieces of food remnant may get stuck on the edges of the conveyor belt. As the cleaning may not be thorough every day due to the time constraints, the food remnant may ferment over time when accumulated, hence dispensing an awful smell from the bacteria. To reduce the odor caused by the food waste, an odor control material, colloidal nanoparticles, can be applied to the conveyor belt. The colloidal nanoparticles are formed by a group of chemicals consisting like iron oxide, silica, alumina, titanium oxide, and zinc oxide, etc. The thin coating of colloidal nanoparticles with an odorless compound is effective in absorbing at least 25% to 65% of odor. It can help maintain a comfortable and pleasant dining environment all the time.
Sustainability can be achieved by the installation of the conveyor belt in twofold. First, by the use of smart materials, applying an easy cleaning coating can avoid the excessive use of water and detergent. As the staff may simply use cleaning cloth to wipe off the oil or water, they do not need to clean the belt with a lot of water or detergent. It can conserve water and less chemical waste is produced. This can attain sustainable ecology. Moreover, the coating can extend the life of the machines. The machines won't be broken so easily, and fewer resources are needed to acquire new ones. From that, more money can even be saved from the repairing budget. This can achieve both ecological and economical sustainability. Apart from materials, sustainability can also be achieved through technology. At the end of the belt, there will be a dumping hole for the dishwashers to dump food scraps in. Below that hole, an energy generator will be installed to convert food wastes to power. As per the way of energy generation, researchers from the Cornell University have come up with a biogas generation method, which will be adopted. Reportedly, a pressure cooker will be installed, and it will turn the food waste into a crude bio-oil, which can be refined into biofuel to partly power the lighting system and the dishwashing area. As for the remnants, they will be broken down into electricity to power the sensor. We believe that the conveyor belt can improve the quality of diner and Hong Kong canteens as well as the work environment of the cleaners. Thank you for watching.